Do you want to automate your Bambu Lab P1 or X1 printer in a simple and effective way using only your slicer and stock parts? Great! Because in this video I will share all my secrets for successful print automation. This includes things like how to fix the purge line issue, safe ejection sequences for small and big parts, how to loop prints, and many more tips and tricks I have learned by auto-printing this egg cup more than 4000 times, printing through day and night without picking off parts or restarting files. Let's get started. The basic print automation principle is always the same. We have a start sequence, printing the model, the ejection phase, and looping everything to start again, all in the shape of one basic G-code file. We will begin with a startup sequence. If you have ever started a G-code file from your SD card, you notice that your printer does not ask whether you want to level your bed or do the LiDAR calibration. It just does it all, like a naughty little rebel, which in our case is unnecessary. It also takes a total of 7 minutes, which can be optimized. To modify the start sequence in Bambu Studio, click on Printer Settings and go to the Machine G-code tab to copy the start G-code. This interface is horrible. So let's copy all of that into a new text file and open it with your favorite text editor, like Notepad++. We will briefly go over what to comment out and add for the X1 and P1. All modified files are also downloadable below, but roughly understanding these G-code parts is important, so don't skip it. Hit the pause button when needed. We will start by disabling the unnecessary first layer scan by adding a semicolon in front of each line. In Notepad++, you can multiply your cursor by pressing Shift, Alt and down arrow. Perfect. Next, we can disable the filament purge. If you want to use your AMS, then leave this part in. If not, you can comment out lines 91 to 102. I prefer turning that violent plastic pooping off. Because we don't use the scanner for the filament calibration, checking its clarity is useless. So out it goes. The P1 of course doesn't have this G-code part. On to the bed leveling. You really only have to do this when you move your printer or change the bed sheet. If you uncheck bed leveling with a 3MF file, the printer will still do a single leveling move in the middle of the build plate. By commenting the whole bed leveling part out, this is lost. So let's add it back in using the G28 command. For the P1, we have to add a G1 move command with the printer center coordinates X128 and Y128 in the line above. We also want to disable the nozzle heating to prevent any unnecessary nozzle leaking. We will add this back later. The resonance frequency check is also only needed occasionally, and sadly it has to leave us as well. I rarely do these basic calibrations, but if you feel the need, I recommend doing them directly through the printer's menu. Next up is the annoying nozzle load line, which is also useless for us. It has to go find a new home. One thing I always do is reducing the Z offset to add more first layer squish and adhesion. Setting it to 0.08mm works best for me. We definitely don't want to do the K-value calibration, so let's comment out a huge chunk of code from line 303 to 642. Comment out line 646 to 648 as well, to make sure no old calibration parameters get saved. To reduce unnecessary nozzle oozing, we will split the heat up command into two. First is the M109 command, to wait for the nozzle to heat up to the first layer temperature, -20 degrees. The printhead will start moving right after this. With the following M104 command, the nozzle will heat up to full temperature during the first movements. I promise this will make sense in a minute. The final thing left is the purge line, which is important to build up nozzle pressure for a clean print start, but annoyingly doesn't get pushed off with the print. We will comment this out and solve this issue later. Now I know this was a lot of information to take in, but you of course only have to do these changes once. Just copy your new start G-code or my downloadable code back into Bambu Studio, and then save the new start sequence in the printer's profile. This time I will let my German creativity run wild and give it a fitting name. Perfect. The new startup does only the essential commands, like homing and cleaning the nozzle. It also only takes around 1 minute and 40 seconds to complete. Awesome. When you first try out your new code, use an old build plate plus nozzle and keep your fingers on the off switch in case something goes wrong. I'm definitely not speaking out of experience, because I have never damaged anything during the testing. Let's continue. Before we start with the print, Here's a little bonus tip for the filament settings. With the door open anyways, you can reduce the chamber fan speed for the printer to be more quiet. Here you can also add custom K values with the M900 command. Let's continue with the model printing. If you like that detailed type of content so far, hit that like button, subscribe, or leave a comment below. Let's finally print the egg cup model with a new startup sequence and take a closer look at the beginning of the print. As you can see, the missing purge line leads to an unclean print start. Now you could say that you don't care, but producing prints with a bottom that looks like this will book you a ticket straight to 3D printing jail. Let's add something I call an in-model purge to fix this. First, we will move the egg cup to the front for an easy push off. This is the egg cup file we optimized in the last video, which already has quite a few of these yellow modifiers. We will add another one by right-clicking on the model, then add modifier and selecting the cylinder shape. Start resizing it to the size of your first layer and around 0.6mm height. Move it to the center of your print and 0.3mm Z height. Click on the modifier and add walls until you get a short first line in the middle of the egg cup. For this model, around 5 walls are perfect. This first short extrusion is exactly the result we want. We will talk about other model shapes later. Now we want to export the sliced model as a G-code file by clicking on File, Export and Export G-code. Now just save the file and open it with your text editor. To add the in-model purge, scroll all the way down to around line 1070 and go to the first G1 extrusion command. We will leave the coordinates as they are, but replace the extrusion length by around 3mm to push out extra filament and increase the initial nozzle pressure. Let's save and print the G-code file directly from the SD card. This is what our in-model purge looks like. Now that was actually a 3.6mm extrusion for demonstration purposes, with bad filament that leaks a little. If this happens, don't worry, it's usually all gone by the end of the first layer. Taking another look at the bottom of the egg cup shows that even this over extrusion would still pass as an OK print bottom. If you get this extrusion number right, like somewhere around 3mm for this filament and print, the start will look clean and the underside of the print looks like something even 3D printing Jesus would approve of. But what if you just can't get a first small extrusion for your model? In my experience, that's rarely the case. Should it still happen, for example with a vase mode print, where we can only have one wall that starts like this, we can add a little sacrifice structure. Just right click on your model, go to add part and add a cube. Resize it into a small stick with around 0.4mm height. Then move the little guy to around 0.2mm height and the approximate start position of your print. It can help to select the model and paint the seam at the newly added part to enforce the correct starting position. We now again have a first short extrusion for our in-model purge. The little helper piece will get pushed off with a vase, and after the print we just take our pliers, snip the little helper off and use our lighter to smooth the cut out. You can barely see it on the finished product, and no one ever complained about it to me. It's a bit of post-processing, but it takes less than 10 seconds and works reliably. As usual, all of my designs shown in this video are downloadable below. A commercial print license is also available on my thanks page. Overall, the in-model purge works great for me, and I had 0 clogs using it over thousands of prints. Now onto the ejection phase. All you need for this is the PEI sheet that came with your printer. PEI sheets self-release the part when it's cooled down sufficiently, which is essential for a safe ejection. Let's modify the end G-code and add a push-off sequence that is efficient and most importantly safe. Like earlier, we copy the end G-code into a new file. This time, everything will be the same for the X1 and P1 printer. We will start by commenting out line 38 to 47. This whole part just makes the bed go down a little after a print, which is unnecessary for us. Let's indicate that the cooldown part is starting and add the M400 command to make sure all print movement is done before continuing with other commands. Now on to the cooldown. One thing I see all the time is people just adding a G4 wait command here. This is dangerous and inefficient. What if your print room temperature varies during the day or seasons? Your printer will either wait too long or in the worst case wait too little and just crash into the still adhering part. Don't do it. We will instead add a M190 command to wait for the printer to reach the target bed temperature. Well, what's the right temperature for my print to self-release? That's something you have to try out once. Just print the model and then use one of your fingers to gently push the part at different temperatures until you can easily release it. For my filament, that is around 22 to 25 degrees Celsius. If you try this command with a Bambu printer, you will notice that the printer will start moving anyways if it hasn't reached the target temperature in 90 seconds. To solve that, we just copy and paste it 40 times for a total maximum wait time of 60 minutes. My genius is frightening. By now you might wonder why I wrote M190 S18 when the target temperature is 22 degrees. Similar to the wait time, the printer will accept the command as finished around 3 to 4 degrees before reaching the target. So S18 here equals around 21 to 22 degrees Celsius. Now let's add a small detail to make cooling down more efficient. Before the cooldown command, we want to move the bed all the way up to 1 mm with the G1 move command. Careful, this only works with tall prints when the top cover is off and the AMS is set to the side. For those who forget to do this, we add the M17Z0.4 command to reduce the Z motor current as a precaution. We did all of this so we can turn on the auxiliary fan and cool down the build plate significantly faster. This is done using the M106P2 command with the S value at 255, which is full speed. We'll turn on the chamber fan as well to help a little. After this optimized cooldown phase is done, we can turn both fans off again using the same M106 commands and S values of 0. If you are in need of even more smart production solutions, check out this video sponsor, PCBWay. PCBWay offers a variety of services including metal 3D printing, custom PCBs and more. Just select your production process, upload a geometry file, select your quantity plus material and get an instant quote for your custom parts at an affordable price. Thank you to PCBWay for supporting this channel. Next up is the push-off sequence, which is just a bunch of G1 move commands to safely eject the part. We start off by lowering the bed using an automated calculation based on the max model height minus 30 mm to actually hit the print head and not the nozzle. For the small egg cup, the resulting height is 3 mm. But this is especially important for tall prints like the vase that have to be lowered after the optimized cooldown to not hit the printer's frame from the inside during ejection. More on this later. Instead of this automated calculation, you can alternatively also enter Z coordinates directly for the models that need a different push-off height. Next up are the print head movements. We will first do a little safety movement to the right to not hit any nozzle cleaner parts. Then we will take the center X push-off position at the back of the printer. Your X coordinate should be your model X coordinate -8 to hit the middle of the printer's tool head, X120 in this case. This is followed by the very slow push-off command with the Y25 coordinate all the way at the front of the printer. Go slowly here. The footage is sped up. This is not the part where fast and furious is the right mindset. Don't forget to add some kind of box to catch your prints, like this beautiful cardboard box the past me chose for this video. The push-off is finally done, but I like to add a few safety clear movements. By now I'm sure you know how these simple back and forward movements are done. This is of course optional, but will make sure to fully clear the print bed in case the rare spaghetti print happens. Let's take our new end G-code and copy it into Bambu Studio like last time to save it in the printer's profile. This whole G-code is also included in the download below. If you slice your model with this new end G-code and enable travel moves in your slicer preview, you can see all move commands we added shown in blue. This can sometimes come in quite handy. We are nearly done with the whole process. All that's left is looping the print to start again. Export the newly sliced model in G-code format and open it. We will first add the in-model Purge like shown earlier. Then go all the way down to the M73 P100 command. This command updates the print progress to 100% to finish the print. We'll just delete it, so the print never ends. Then we copy the whole file and paste it in as many times as we want to print the model. Looping prints is that easy. We can now save the file and print it from the SD card. Now I know you can also use third-party software for print looping. Use whatever method you prefer. Before we talk about increasing efficiency and safety even more, let's do a short recap on how to use everything we have learned so far. I did promise this would be simple. So here's the process you have to do for every new model once you have the basic setup. First select our new printer profile. Then position your print at the front of the edge for easy ejection. Now check the end G-code to make sure that the Z push of height is right for your model. The X push of coordinate is also okay for your model, or enter new ones. Make sure your print starts with a short extrusion near the center of the print, or add a little helper piece. Then slice your model and export it as a G-code file. There, add the in-model purge to get a clean print start, and erase the M73 P100 command at the end of the file. Loop the print by copy and pasting the G-code. Now you can print that G-code file from your SD card. For a new model, this whole process takes me only around 2 minutes to set up. It's simple once you understand how it works. Now you might say this is inefficient because we have a model print time of around 30 minutes and a cooldown time of, let's say, 12 minutes. That's 28% of printer downtime. Not great. For longer prints, this is of course less of a problem. When using small models, we can just fill up the whole front edge with copies. For the egg cup, we can print up to 4 at once. Then we push them off separately. Just make sure not to hit the carbon rods and push them off from right to left to not hit your LiDAR sensor. I would not recommend adding a second row. This is what the end G-code looks like. Hit the pause button if needed. Our model print time is now 1 hour and 57 minutes, with again 12 minutes cooldown, which comes down to only 9% printer downtime. Accepting a short printer downtime, so I don't have to be there at specific hours to pick off and restart prints, is completely worth it in my book. This way, my printer can even work at night, when my weak flesh body has to rest. On to more safely ejecting bigger objects. What I didn't show you earlier is that this footage is rotated and the printer is slightly tilted forward. This makes ejection easier as the parts always fall out the front. Doing this is of course optional. You can even take this a step further for big prints like this plant pot and print them with your printer upside down. Why, you ask? Well, this way the print just falls off the build plate once the cooldown phase is done, without your printer doing a single push-off. You of course have to cut a square hole into your desk for the part to fall through. I still like that desk, so we'll skip that here. The obvious drawback is that the filament purging doesn't work anymore, but I did show you earlier how we can disable that in the start G-code. Now you might think that printing upside down changes anything about print quality, but I am by no means the first to try this, and it doesn't seem to affect the quality at all. This planter turned out beautifully, and even the fully printed push lock mechanism for the hidden box on the underside works great. This does not work with subpar print quality. On to the next question I get asked all the time. What about washing your PEI plate? Well, you just don't. Unlike us, the printer doesn't have naturally oily skin, which dirties the print plate during pick-off. Stop touching that plate. I literally print hundreds of egg cups at the same spot without cleaning once. If you do clean it once in a while, use a fresh sponge and dish soap. None of that isopropyl alcohol. Then completely rinse it off with water afterwards, like Bambu Lab recommends as well. This works way better for me. Try automating your own printer and comment below if this video has helped you out. Click here for more videos like this one, and thank you for watching.